Bruker enables scientists to make breakthrough discoveries and develop new applications that improve the quality of human life. Introducing Bruker's new timsTOF Pro, powered by passive technology, designed to give world record sequencing speeds and high sensitivity, enabling you to gain deeper coverage and identify more than ever before. Bruker's new nano-elute UHPLC offers excellent chromatographic performance in terms of separation and reproducibility for even the most complex proteomic samples. In the timsTOF Pro, the TIM separation occurs on the millisecond time scale, enabling the speed of the passive method to keep up with the complex and rapidly changing mixture of peptides eluting from the nano-elute LC column. The timsTOF Pro enables the usage of all peptide ions that enter the mass spectrometer due to its unique TIMS technology. Peptide ions are accumulated in the first part of the device, whilst trapped ion mobility separation occurs in parallel in the subsequent region, resulting in very high spectral quality. By applying the passive or parallel accumulation serial fragmentation method, hundreds of MS events per second at very high sensitivity and full resolving power are generated by synchronizing the quadruple mass isolation position with the period of time the trapped ion mobility separated ion species elute from the TIMS device, typically just a few milliseconds.
TIMS and passive have a great promise. So basically in principle, they add another dimension to the separation. And we now know that the peptide mixtures are way too complex to resolve them with the two dimensions we have. And so adding one more dimension should in principle get us a long way ahead.
In the typical example shown here, passive enables MS spectra of 12 precursors, resulting in an extremely fast MS acquisition rate. The MS and MS sensitivity in passive is increased by time focusing of the ion packets by the trapped ion mobility separation. Passive further increases the MS sensitivity for less intense precursors by allowing for the selection of these several times for fragmentation. Through unlocking a fourth dimension of separation, peptides can be clearly separated with the timsTOF Pro, which could not be separated by mass spectrometry alone.
Yeah, so the advantage of the timsTOF with the passive are that we get another dimension of separation, so we know more about the molecules, they're better to identify, faster to identify and quantify, and as a result the throughput and also the robustness should go up tremendously.
timsTOF Pro, the new standard for shotgun proteomics.
Dr. Sarah Yang is responsible for cancer drug target screens in hundreds of cell lines. Using classic bottom-up proteomics methods, she needs to run hundreds of samples with 2-hour gradients. Only after each run is complete can she begin a database search, then will have to wait days to view the results. Because Sarah has a project team meeting the following day, she'll have to make assumptions based on incomplete datasets without proper replicates to confirm the new findings. This makes Sarah very uncomfortable in a room full of critical experts. After promising replicate data for the next meeting, Sarah finds her instrument was already showing reduced sensitivity and inconsistent results. There goes the weekend. Sarah will be spending precious time cleaning ion optics. But what if she didn't have to wait? What if it was instant? What if she not only reproduced her data the same day, but could investigate other leads and still have her weekend to relax, knowing her instrument is the most robust in its class? Fortunately, Sarah's lab invested in the timsTOF Pro Bruker's mass spectrometer that has revolutionized bottom-up proteomics with its industry-leading robustness and speed while being 4-dimensional. But wait, won't generating more runs per day mean more time required for processing data, pushing the bottleneck downstream? Again, Sarah's visionary investment in the timsTOF Pro will pay off. She'll now have access to PACER, a revolutionary informatics technology that analyzes tandem mass spectra in real time, introducing the concept of run and done. PACER's inventor, Robin Park, and his mentor, Professor Dr. John Yates, realized real-time directed mass spectrometry was possible by pairing PACER's proprietary algorithm with the speed of Bruker's timsTOF Pro. How does it work? First, ions are detected. Then PACER assigns peptide sequences in less than 5 milliseconds by harnessing the power of modern GPU chips and massively parallel computations. This enables real-time decision-making while the mass spectrometer is acquiring data, making Sarah's timsTOF Pro and her experiments smarter with every scan. Because data is searched in real time, the results are completed at warp speed. This is called run and done. Bruker believes the omics ecosystem should be open access and will provide a marketplace in which to share and exchange user-designed programmatic capabilities. With this free exchange of ideas, the possibilities are truly endless. Sarah can now say goodbye to her frustrations caused by low throughput and slow data analysis, and hello to the new game-changing technology of tomorrow, the Bruker timsTOF Pro with PACER.